Hi, this is Tim Hubbard, supervisor of the great town of Riverhead, and you're watching Riverhead in Action, a media campaign designed to highlight the incredible work of the 350 plus employees that comprise Riverhead's 26 departments and sub-departments, town events, projects, job openings, local businesses, and other town happenings. I hope you find this informative and enjoyable, and thank you for watching Riverhead in Action.
This is the Riverhead Water District project to replace well number 2. It'll be well number 2A. It's being drilled with a reverse rotary rig. This is what it looks like. The material's drilled out of the ground, ends up in that pit where the operator empties out of the pit. We call that cuttings. And I'm going to show you the cores next in which we designed the well from. During the drilling process, when we're in the potential screen zone, we collect core samples of the aquifer that go through the drill stem, and we take this thing called a split spoon apart, and these are actual samples of the aquifer, starting at 198 feet, 210, 220, 230, and so on. You can see that this is the Magathy aquifer because of the sand, the gray colored sand. It's fine to medium grain, and it has biotite mica in it. It's pretty typical of the Magathy, and this is likely to be where our screen zone is. I'll use this material to do a sieve analysis and design the final well screen and gravel pack, and this will be part of the decision I make on where to put the actual well screen, but there'll also be some geophysics involved to confirm that this is a good area for the proper yield of a production well. What we wouldn't want to see is what we're seeing in some of the newer cores, which is clay in the aquifer. So it wouldn't be good to screen this as a production well because you can see it's clay and it's not likely the water's going to move through there well. We see a couple of different clays. This is what we're not looking for, and this is what we're looking for. Hello, this is Frank Mancini from the Riverhead Water District with another one of our capital improvements. In this case, we've installed 2 granular activated carbon filters that we call GACs. And these are to remove PFAS from our well 5-1. They work just like a gigantic Brita filter. Inside these vessels is 40,000 pounds of carbon apiece, and that carbon removes the PFAS from our drinking water. Thank you. Hi, this is Frank Mancini from the Riverhead Water District again, and we're at another capital project. This is the 2 filters I just showed you, how we get them to work together through our sophisticated control system. As you can see, this is a screen interface where we'll be able to touch and tell it to do certain things. When we open up these panels, you get to see how complicated it really is. All these wires are connected to individual end devices like flow meters, valves, and they monitor the position of those instruments and report it back to our centralized computer system. And that's how we're actually to control all these systems electronically. That's called the SCADA system, the Supervisory Control and Data Acquisition. So this is the latest of technology. We're happy to be implementing it. Hello, this is Frank Mancini from the Riverhead Water District with another one of our capital improvements. In this case, it's a manganese removal plant. So this is again for our well 5-1. We take the groundwater has naturally occurring manganese in it. We treat that water with chlorine, which causes that manganese to oxide, becoming a particle in suspension where it was a particle in solution. Once that particle, which is a little piece of rust, enters these filters, there's graded beds of sand in here, and that manganese particle gets stuck to the top of the beds. We keep pushing water through it. At a certain point, there's so much manganese stuck to the top of the bed that it restricts our flow through the vessels. At that point, the vessels come offline one at a time, and they're backwashed where that manganese is discharged to basins we have outside. And then this filter is returned to service and operating again. Thank you.